Hey there, and welcome to today's Explainer. So, today we're tackling a subject that, honestly, sounds pretty intimidating, but it's actually beautifully intuitive. We're talking about machine learning. Now, if you've ever felt completely overwhelmed by all the coding jargon and the wildly complex math that usually surrounds this topic, well, take a breath. We are going to strip all of that away today. We're going to demystify the core concepts and show you that really how machines learn isn't all that different from how we learn.
I mean, just think about this for a second. How did you actually learn to read messy handwriting? It's kind of crazy when you think about it. Nobody handed you a rigid rule book dictating that an A absolutely must be a perfectly closed loop with a straight vertical line, right? If they had, you literally wouldn't be able to read half the grocery lists in the world. Instead, you just saw hundreds of examples. Over time, your brain quietly built its very own understanding of what an A looks like, accommodating all those wild, messy variations.
And that brings us to a really important contrast. On one side, we have the traditional approach, explicitly programmed rules. Basically, if you wanted a computer to do something, a human had to sit down and write a hyper-specific rule for every single possible scenario. But, as you can guess, rigid rules totally fail for complex tasks. On the other side, we have exposure to examples. This is exactly how the human brain learns, quietly building understanding through repeated exposure. And the amazing part? We've actually figured out how to let computers do the exact same thing.
Okay, let's dive into this. The official core definition. Machine learning, or ML, is basically a branch of artificial intelligence where a computer improves its performance on a task by studying data rather than being explicitly programmed with rules. So we're essentially swapping the human brain for a computer program. And instead of calling those handwriting samples experience, we just call them data. The machine is figuring out the rules all by itself, and this whole process follows a very specific life cycle. We can think of this as the machine-student journey. It maps out the chronological life cycle of a machine learning system directly to a human student's journey through school. It is a super simple three-step process. First, you have data, which acts as the textbook. Second, training, which is the studying phase. And third, testing, the final exam. If you keep this student analogy in the back of your mind, you will never get lost in the technical weeds.
So, step one is data. This is simply the examples a system studies to learn a task. Data is the absolute foundation here. It is the machine's textbook. But you have to remember, this textbook contains thousands or even millions of examples. Like, if you want to teach a system to recognize spam emails, your textbook is a massive pile of real emails clearly labeled by humans as either spam or not spam. Without it, the machine student literally has nothing to learn from.
Right, so once we have our textbook, we move right along to training. This is the studying phase. It's the process of a system actually adjusting itself based on that data to improve at a task. The algorithm looks through that massive pile of data over and over again, finding underlying patterns and tweaking its internal settings. Just like a super dedicated student doing hundreds of practice math problems to perfect their technique, the computer is doing the exact same thing.
And after all that intense late-night studying, what do you actually get? You get a model. The model is the trained system that has learned those patterns and can now make predictions. If training is the studying, the model is the fully trained student ready to graduate and take on the real world. But obviously, before we release this model into the wild, we got to make sure it actually learns something valuable.
Which brings us to testing. This is checking the work with brand new examples. Think about a student who just memorized the practice test answers without actually understanding the subject matter at all. I mean, they're going to bomb the real exam, right? To check if our machine student genuinely learned a pattern or just memorized its textbook, we show it completely unseen examples. If it can correctly label these brand new emails, then we know for sure true learning has actually occurred.
So how do we grade this final exam? Well, we look at its accuracy. That's just how often the system's predictions are actually correct. This is the machine's final grade. Now keep in mind, no machine learning system is absolutely perfect. Just like us, they make mistakes. The goal isn't flawless perfection here. It's just getting the accuracy high enough so the system is genuinely useful and reliable in the real world. And this brilliantly illustrates that idea. If we look at a system with a 97% success rate, like in our email example, this means our spam filter correctly identified 97 out of 100 brand new unseen emails. Honestly, that is an A+ in the real world. Sure, 3 emails slip through, but a system performing at this level is saving human beings an enormous amount of time. To really anchor this whole student analogy in reality, let's consider a tool almost all of us use every single day, Gmail's spam filter. Gmail didn't get this good at blocking spam because some Google engineers sat down and wrote a million explicit rules. No way. It got effective because it was trained on enormous numbers of emails that human beings had already flagged. Every single time you click Report Spam, you are actively providing labeled data for that machine student's textbook.
And because the filter learned underlying patterns rather than just following a rigid, fixed checklist, it can catch brand new spam tactics it has never technically seen before. Spammers are constantly changing their tricks, right? But the model looks deeper. It looks at certain phrasing, unusual sending behaviors, suspicious link structures. It basically learned the true vibe of spam, adapting to new threats instantly without needing any new programming.
Now, it's also absolutely crucial to bust a really common tech myth here. You will often hear that machine learning always needs massive, enormous amounts of data, but the reality is actually quite different. While more data definitely helps, a smaller set of really clean, well-labeled examples will often drastically outperform a giant pile of messy, inconsistent data. Quality matters just as much as quantity. It's exactly like how a student learns way more from one clear, well-written textbook than 10 filled with typos and errors.
So, the crucial point is that machine learning is incredibly logical. Computers study data instead of following rules. Training is how they learn. Testing with new examples proves they actually understand, and accuracy is their final grade. The jargon might sound super complex, but the underlying concepts follow a very relatable human journey of learning.
I want to leave you with this final thought. Try turning the lens back onto yourself for a second and just consider your own daily data footprint. Think about the messages you send, the photos you upload, the purchases you make, the searches you type in. What patterns actually exist in your data? And more importantly, what could a machine learning model learn to predict about you by studying it? It is a fascinating and maybe slightly sobering question to ponder. Thanks for joining me for this explainer, and keep questioning the data around you.